So now let's look at some examples. So we want to sketch the graph f of x equals 3 to the x. Okay, so we use the way we know that the base b is equal to 3. It's greater than 1, so the function should be increasing function, right? So we want to plot some points to sketch the graph for this problem. Okay, so first let's pick some sample points. This is the x values, this is the f values, okay? So if we pick x equals 0, we know it must be equal to 1. So this point is always on the graph. 0, 1 point. If x equals 1, y equals, or f of x equals what? 1, so it's equal to 3. Right? If x equals 2, that would be 3 squared, so it's 9. Okay, so let's take some negative numbers. If x equals negative 1, so this would be 3 to the negative 1. We just know the rule, right? It's equal to 1 over 3 to the 1, which is equal to 1 over 3. Okay, so we use these points, try to plot this function. So this is the this is the x-axis, this is the y-axis of the f values. So it's 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. Okay, this is 3. This is 6. So 0, 1 is on the graph. And what about the other one? 1, 3. So this is 1. 3 is here. 2, 9 is here. And the negative 1 is here. Negative 1, 1/3. 1/3 is here. Right? You can imagine it will go down when x is decreasing. So let's connect these points, use some smooth curve. I use different color to help you to understand. We connect, use some smooth curve to connect so this is our graph. Okay. You can see another graph. Another example, which is f of x equals 1/3 of x. Okay, so we have some table. We pick some f values. 0, when x equals 0, 1/3 to the 0, always 1. When x equals 1, then this would be 1/3 to the 1, so it's 1/3, right? 2, it's too small, so it's not convenient for us. Let's pick some negative numbers, negative 1, so which is 1/3 to the negative 1. 1/3 to the negative 1 is if you want to get rid of this negative sign, you need to flip the base, right? So it becomes 3 to the 1, so which is equal to 3. Negative 2, 1/3 to the negative 2. So it's the 3 to the square, right? 3 to the second power, so square, so it's 9. So now we use these points to draw the graph. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. This is 6. This is this is 3. Okay, and this is the -1, -2, right? And 1, 2. Okay, so 0, 1 point is here. This is 0, 1 point. 1 and 1/3 is here. This is a 1, so this is 1/3. So here is. And we have -1, 3 point is here. We have -2, 9 is here. Okay, so let's use some red color to connect these points. So we know that if you use some smooth curve to connect it, then you know we will never cross x-axis because x-axis is the horizontal asymptote. Okay, so now we want to use the next example is we want to use some properties to solve some simple equations. So the first one is the 2 to the 2x equals 2 to the 6. So since they have the same base, do you remember we have this one, a to the x equals a to the y, if and only if x is equal to y, right? So we use this property to solve this kind of equations. So that means the exponent should be the same because they have the same component, same base, 2, right? Then here you divide by 2, so you have x equals 3. Okay, this is the first example. The second example is for this property, 7 to the 2x plus 5 is equal to 7 to the 15. So since they still share the same base, 7, so the exponent should be the same. 2x plus 5 equals 15. So 2x minus 5 on both sides equals 10. So x equals 5. Okay. The third one. Three to the x plus 4 equals 3 to the 2x minus 5. Okay, so here you should be careful, okay? And this one is not 3 to the 2x minus 5. They are different, okay? So we always have students make this kind of mistakes. They put this constant down. Remember, this constant 5 is on the exponent, okay? Because the size of this 5 is smaller than this 3. So that means this kind of writing means this 5 should be in the power, okay? So from they have the same base 3, 3, so the exponent should be the same. 4x plus 4 equals 2x minus 5. So we subtract 2x on both sides. So subtract 2x, so you have negative x, right? Plus 4, negative 5. Then subtract 4 on both sides. You have negative x equals negative 9. So you divide by negative x, so it would be 9. Okay, so now we want to talk about some application problem for the exponential functions. We have many application problems for the exponential functions. So during the application problem, one thing you should be careful is you should be able to use your calculator to do some calculations. Okay. So you'd better to check your manual of your calculator to see how to use your calculator to do some calculations involving the exponent. Now let's look at this example. So one application for the exponential function, which is called the exponential increase or the exponential growth or the exponential decay. Okay, so once this is the example for the exponential decay. So here the function f of x equals 600 times 0.5 to the power t over 80. So t over 80 is the power. This function models the amount in pounds of a particular radioactive material stored in the concrete vault, where T is the number of years since the materials was put into the vault. Find the amount of the radioactive material in the vault after 140 years, rounded to the nearest whole number. Okay, so here, so this problem tells you that t is equal to 140. So you just need to plug in to the function. Okay, so it's actually when we do the calculation, so we calculate t equals, so here we figure out t equals 140. So what is the f of 140? So after 140 years, how many pounds of the radioactive material left? So it follows this rule. 600 times what? Let's go back to see. It's 0.5. The power is t over 80. So this is the 0.5 times t over 80. Okay, sorry. So here we should plug in t equals 140. So it should be 140 over 80. Okay, so when we do the calculation, use your calculator. Okay, you should be able to use your calculator to do the calculation. So the first thing, of course, you can use your calculator to do the calculation for all the things together. But I suggest if you are not familiar with your calculator, you'd better do it step by step. Okay, so here I will show you how to do it step by step. So the first thing is, let's do the calculation for the power, right? We cannot do the 600 times 0.5 first, no. We have to figure out what is the power. We should 140 divided by 80. Use your calculator, you will see it's 1.75. Do not round the numbers, okay, this number. Although at last you need the nearest whole number, so that means should be an integer, but you cannot round your number during your calculation. Otherwise, you will get some errors, okay? So you have 1.575. Then we do the calculation for what is the 0.5 to the 1.575. Okay, so this is the 0.5 to the 1.75, which is equal to, so the first thing is you'd better to keep this number as many decimals as possible, okay? 0.297301779. So this is the number I copied from the calculator, okay? So don't round to any round. For example, you don't round to 2 decimals, okay, or don't round to 1 decimals. You will have some errors, okay. So just keep as many decimals as possible from your calculator. Then we use this number multiply by 600. Okay. Okay, then you will have. So now this is the final answer. Now you can get your answer. Okay, it is 178.381067. So, but our problem is nearest whole number. So just take the integers, round to the integers, the nearest integers. So it should be 178. Okay, pause. So this is the problem, one example. Let's look at the next one.